Okay, so trapezoidal method. First of all, you guys pretty much know how to complete or solve using the trapezoidal method once you have found the left and the right endpoint. But here, if you are given, this is just in general, if you are given a curve and you had to create the trapezoids, which is what I did here on your paper, you have your initial endpoint, which is x sub 0, and then all these other endpoints. So what you create underneath this curve are a series of trapezoids. So I showed you in the notes that if you turn this on its side, this is delta x, which basically is your height when you're looking at the trapezoid using this method. And this is your first base and your second base. Then this is your first base and your second base. First base and then second base and so on for each trapezoid. So what I want you to see here is the pattern. So for those of us that have forgotten to find the area of a trapezoid, it's 1/2 the height times the sum of the first and second bases. And when I say the base, just like I said, when you turn it on its side, you have the top and the bottom. So if I'm looking at each trapezoid here, which is what I've indicated, we have the area of the first trapezoid, which is going to be 1/2 delta x times f of x sub 0, because that would represent this height right here, which is the first base, plus f of x sub 1. Okay, so I created this table. Now keep in mind too, you could have more trapezoids, you could have less trapezoids, okay, but this is just an example. So then when I move to the area of the next one, this is keeping in mind that delta x is going to be the same. Okay, it could be different. So if I were to continue, I would have 1/2 delta x, which represents my width, or in the case of the formula up here, it would be the height if I turn it on its side. And then when you have this first base, so now I'm ignoring this trapezoid and I'm only looking at a sub 2. A sub 2 is made up of f of x sub 1 plus f of x sub 2, meaning this is my base here and this is my base here. Yes?
If it was like different, if delta x was different,
it would be whatever this, so let's say if this is 0 to 2, I'm just making this up. If this was 0 to 2, you'd put a 2 in here. If this was 2 to 3, then you'd put in a 1.
Okay.
So then you would have to be able to look at it if you created these, so you'd have to somehow know what your width is. Typically, when you're reading the problem, it's going to say of equal subintervals. So if you have something like that, or you're looking at the table, you're going to be able to tell that delta x is either the same or different. Does that make sense?
Yeah.
Okay. So then here, this next trapezoid would be 1/2 delta x times, and then we have f of x sub 2 plus f of x sub 3. And really what I'm setting up here is, what is the formula in general? So I'll just do one more trapezoid, which again is 1/2 delta x, which is going to represent my height. And then you have f of x sub 3 plus f of x sub 4. Okay, so if this is in general, what we're looking at is, what do they have in common? So if you notice here, if these are all the areas, and I'm looking for the area under the curve, I'm looking to see what they have in common. So if you notice here, you have f of x sub 1 is going to be in common, and then f of x sub 2 is in common, f of x sub 3. So really, if I had a series of formulas here, they would all be on the diagonal. So anything that's in the middle, you actually have 2 of them. So when I'm looking, because the bottom base for the area for sub 1 is the top base for the area of trapezoid 2. Then the bottom for 2 is the top for 3. The bottom for 3 is the top for 4, and so on. And that's going to keep going because they're adjacent to each other. Does that make sense? Okay, so I know this sounds silly, but I like to think about this as like building a sandwich, where you go into a deli and you can build any kind of sandwich that you want. And then in order to hold it all together, because you're going to have all this stuff in the middle, you need a toothpick, and to make it look nice, you put a little olive on there. You guys have ever seen that? It's just an analogy, but it's just so you can kind of keep this in your mind. So what we have here, this right here would be the bottom piece of bread, and this would be the top piece of bread, or vice versa, whatever. Top, bottom, it doesn't matter. You have 2 pieces of bread. Boom. Okay? So then what I have, and what all these have in common, is 1/2 delta x. Because typically something like this, if you're using the trapezoidal method, you're going to have the same height, which is represented by your width. Okay? Times. you only have one bottom piece of bread. Okay, it is only that kind of sandwich. You'd have to pay extra for this, and we don't want to pay extra. Okay, so we have f of x sub 0, okay, plus. Then you can get double, because this is a deal that they're running for the day, double whatever you want in the middle. So for those of us that are not meat eaters, you can put all kinds of veggies in there, right? Okay, but this is just an example. I could have double turkey, because I don't eat red meat, f of x sub 1, plus, I don't know, double cheese, sorry, non-dairies, 2 times f of x sub 2, plus, I want double tomato, pickles, whatever. It doesn't matter. What I'm saying is anything that's in the middle is going to be doubled, okay? And then I have my bottom piece of bread or my top, whichever way you want to think about it, plus f of x sub 4. So remember I said, I need something to hold it together. This is my olive, this is my toothpick. So then you put it in there and everything gets held together. I know it sounds ridiculous, but it's just something that you can think about. So if I'm looking at the table, these two ends right here are going to be single. Okay? Everything else in the middle, in between, will be doubled based on the pattern. Okay? So, how many of you actually did the table on, or did the problem for page, I think it's page 6. It's the XG. Oh, wow. You're really getting on top of that. I asked you guys to do one thing other than study for the midterm. I told you to do the problem on page 6. Yeah. I said you didn't have to do the graphs, but you had to do the problem. Yep. So here's the trapezoidal. So I want you on the page 6 that you have to do. Okay. I shouldn't have to check it. You guys are all big boys and girls. In calculus, it was one problem. You need to do the left and the right divided by 2, and I want you to check it with this answer. Okay, because this is trapezoidal. Check? Everybody understand those instructions? Okay. So we're going to use the trapezoidal method, and what I did was I already set up the table. The problem was to find the area under the curve from -2 to 4. They gave you the function of x cubed, and they wanted 3 equal subintervals. That's what the problem said. Okay, so what I did was I started with the table, and I had to figure out what delta x was. So for those of us that have forgotten, how do you find delta x? B minus a divided by n. Okay, I'm looking here. What is b? What is a? Look here. It's somewhere. What's b? It goes from a to b. So it's 4 plus 2. Yeah, because this is going to be 4 minus a -2 divided by, n represents the number of trapezoids in this case, divided by 3. So delta x is equal to 2. Okay, this is important for a couple reasons. Number one, I need to set up my table. So if I'm going to start at -2, I add 2, I get 0. I add 2, I get 2. I add 2, I get 4. So, bless you, I'm going from -2 to 4. Everybody good? Okay. This actually is the setup for everything. Agree? Left, right, midpoint. How would I find my midpoint if I had to do it? Yeah. Well, you wouldn't use the finger. That's if you're given a table. So I know you're given a table here because I did the math for you, but this would be what. So what's the midpoint between -2 and 0? -1. Is that what you were referring to, this one? Or were you saying you just add them together? I was trying to read your sign language. Okay, that's if I gave you like a big table. This one we can actually calculate it because we have the function. So this method that I told you was a really hard one, you use that when you're given the table and no function. Like remember that last page, the tabular method? So you did, something was retained. I'm just teasing. Okay, so in this case this would be what? -1? What would this be? 1, what would this be? 3? Yeah. Okay. Everybody okay so far? All right. So if I'm using this trapezoidal method, meaning I'm not finding left and right and dividing by 2, I'm just using the trapezoidal, we're going to use this. So it's 1/2. What is delta x in this case? It is 2. We found it times 2 times. So remember, it's f of x sub 0 plus 2 times f of x sub 1 plus 2 times f of x sub 2 plus 2 if I have another f of x sub 3, and then I have my other. So in this case, if I use my sandwich analogy, what are my 2 pieces of bread? -8 and, that's right. So then what are my sandwich makings? Yeah, 0 and 8. Does everybody understand what I'm saying? I know it's, Katie's like, nah, I don't get the sandwich. Okay, so this is my end, this is my end. These are my breads, okay, remember, up here? So then anything in the middle is going to be doubled because one is used as the bottom base and then again it's used as the top base. Okay, so here I have, and I'm going to write it in the notation, this is f of -2. I'm making my sandwich. This is my bottom piece of bread. Plus, I'm going to have 2 times f of 0 plus 2 times f of 2 plus, do I have 2 of these? No, I don't get double bread. So this is f of 4 because this is my end. This is where it's helpful for you to make the table first so you can see what you have. So now, this is 1/2 times 2 is just 1. 1 times f of -2 is -8 plus, we know this is 0, but I'm just going to write it, plus 2 times 8 is 16, right? Plus 64. Okay, did I mess up my math anywhere? Yes?
So if you have like a parabola that you're finding the area under, can your trapezoid's base like different ways?
Yeah, because the one on the left is going to go like this, and the one on the right is going to go, yeah.
Yes, they don't have to all be.
That's correct.
Okay.
It just depends on your curve. Yeah. Okay, so then when I add these together, you have -8 plus 16 is 8 plus 64 is 72. Okay, so when you guys complete page 6 and you find the left and the right and you add those two together and divide it by 2, it should be 72. Okay, so you need to verify that this works. You should get the exact same answer, not approximate, exact. Okay, does everyone see how this works? This will be very helpful when you complete one of those problems. I think it's like the second or third problem on page 8, which is your homework after the midterm part of it. Does anyone have any questions on the trapezoid? Are you sure? Okay. Done. Put that with your notes. Thank you for paying me attention. Hi. Okay. C.
Oh, you know the lab right? Never do that.
I thought you got it on your way up.
Yeah, I have it. I haven't even like looked at it. I didn't even do the freelance, so I didn't even study that. I didn't want to. No, I did not think so good. And I don't have time to do it right now. Sorry. No, it's okay. I don't even think I brought my maid and then she goes over the questions. I just forgot what's after. It's like I looked so much, but I don't know. Because I was like, yeah, I have a person with you guys. And I was like, good, great, yeah. Keep everything like last year. Good idea.
I love it. If I were to try and force that roll on you, I would be like the biggest.
I think, oh my god, I would so much. It's so, everyone does that. I'm so glad it's not genius.
So you've heard of this lunchbox?
Yes. I will never cry. I was like, oh my god. I was like, oh my god. Another day of being alive.
Yo.